Well, so over to Mattias.
Hello, everyone. I know you're all very tired and that this is the last talk, but I really think that you should listen up, because what I'm about to tell you and what I'm going to show you in this demonstration will make you able to access pretty much any AngularJS app out there. And to do that, we can read the title, Breaking AngularJS JavaScript Sandbox. Lightning Talk by Avli Dinbrunn, which is what I call myself on Twitter, IRC, and other shady places around the internet. But for anyone who doesn't know what AngularJS is, let me just tell you real quick. AngularJS is a JavaScript framework for building single-page web applications. You include this script made by Google, and it will give you some new great features that you can use while building your HTML. For instance, one of those features is mustache-style templates. So if you write 2 curly braces in your HTML code when you're coding with AngularJS, and inside those curly braces you can write an expression. And before the page renders, AngularJS will take these expressions, evaluate them as JavaScript, and print out whatever it became on the page. But for anyone who's into web security, you're probably thinking, if these are evaluated with JavaScript, why not put alert1 there? And we have an XSS, right? Well, they're not only evaluated. First, AngularJS interprets what they contain to make sure that you are not using any dangerous objects, for instance, the window object, and you can't access the DOM. Because if we could do that, that means that instead of doing script alert1 for our XSS payload, we could just do curly braces and alert1. And why is that worse? That is worse because even if these templates are HTML entity encoded, which is the default protection against XSS, AngularJS will gladly decode it and then execute it. So if we could do that, that wouldn't be very good. And of course, I did that, and now I'm going to tell you how. Since we can't access these dangerous objects, because it's executed in an empty scope, we need to execute JavaScript from JavaScript. Because if we can execute JavaScript from JavaScript, it will execute in a new scope, which will inherit the global scope, which is window, where we can access all these dangerous objects. So how do we execute JavaScript from JavaScript? We can use eval, but for that we need a window object, so we can't reach that. We can document.write, but that's under document, which is a dangerous object. We can redirect the browser to a JavaScript URI, but then we need a location object. But we can also do something else. We can use the function constructor to create a new function, like I told you, and execute that. And that could work, even though we don't have an empty scope. But unfortunately, AngularJS reads these templates and interprets them and says, no, you can't access the function constructor directly, because then we throw an error and you're screwed. So what else is there? Well, it turns out it's pretty damn hard to execute JavaScript from JavaScript without these things. But the good thing about really damn hard is that it's one step better than impossible. So after a lot of digging into how the hell JavaScript works, and still being kind of sane, I came up with, well, this. And believe it or not, this is a perfectly fine and valid JavaScript way of executing alert1. And this might look like Greek to the most of you, but I'm going to spend the rest of this presentation just quickly describing how this works and how we can use it to attack the AngularJS sandbox. So let's start looking at the second part of this payload. What does this do? Easy peasy. It creates a new array. First element is a string with A. Second is a string, alert1. Then it calls the native array sort function, and it gives it one argument, which is toString.constructor. ToString is a native function, and its constructor is this function constructor that I talked about. So we can simplify this code by doing this. That is the same thing. To understand the next part of this sandbox bypass, we need to look how the native array sort function works, because we're using that here. It works like this. It takes one argument, a function, and that function will be called in the sorting algorithm to determine if the element was bigger or smaller. So the pseudocode, the JavaScript engine will look something like this. If compare function element 1, element 2 equals 1, then something bigger. If it's 0, same, otherwise smaller. This is basic stuff. So if we put in what we wrote here, function, and a and alert1, we get a pseudocode that looks like this. If function a alert1 equals 1, etc., etc. So to simplify this, we must look at how the function constructor deals with multiple arguments. What happens if you just write function a alert1? Well, the function constructor works like this. The last argument will become the function body. All of the arguments previously will become arguments to the function it creates. So if we feed it with a and then alert1, it becomes an inline function, something like this. So now we have if function a alert1, etc., etc. And this is crucial to this, because now we know that by only creating an array and sorting it using the function constructor as a sorting function, we have created a new function. And that's good, because if we can execute this function, we have successfully bypassed the sandbox, because then it will be executed in the global scope. So how to simplify this? To simplify it one more step, we must know how JavaScript compares functions with integers. Because if, like you can see here, we have two equal signs between an integer and a function. And a sane language would just say, well, these are two different types, so you can screw off. But not JavaScript. JavaScript will convert both the left-hand side and right-hand side to a string, and then compare the strings byte by byte. So how does it convert these objects to strings? Well, turns out that there's a native function for all objects called toString. And this is extremely interesting, because this means that we can create a function that we can put whatever function body we want inside of that function, and the JavaScript engine will call toString on that function. Well, what if we override the toString function with the call function? The second part of this payload overrides the function prototype toString with the function prototype call. So when the sorting algorithm uses this function, it will look something like this. If function.call equals blah, blah, blah toString. And what's important to see here is that this red part here is a perfectly valid way in JavaScript to create a new function and execute it. So with some prototype overriding and sorting this array with the function constructor as a sorting algorithm, we have turned this into this. And like I said, even though the Angular website uses HTML entities for this big-ass, mustache payload, AngularJS will just decode it, and then boom, you have alert1. And this works on, I would like to say, almost every AngularJS app out there today. However, I'm not going to be a douchebag and talk about how you break things without actually making sure it gets fixed too. So in the newest version of AngularJS 1.2.24, this is actually fixed. But that was released like 2 days ago. So, you know, if you want to play around with this, I think now would be a good time to start replacing your script alert 1 with that. And that's all I wanted to share with you today. I hope you all learned something about AngularJS, breaking JavaScript sandboxes, or at least had as much fun as I did while presenting this. That's all.